Okay, with problem number 7, we're given this diagram, which is an octagon that is made up of line segments connecting those 8 points on the coordinate plane. And we're asked for how many angles theta, where theta goes between 0 and 2 pi, will rotation about the origin by angle theta map the octagon in the figure above onto itself. Now, a rotation, first of all, is always done in counterclockwise motion. And so what I want to do for this is, I think it should be clear that the answer is either going to be 1 or 2 or 3 or 4 of those, possibly 8. If there were only one answer to this, then that would mean we would only be able to turn this 360 degrees. Only by turning 360 degrees would we be able to map it back onto itself. For 2, it would mean that we could turn it 180 degrees, map it onto itself, another 180 degrees, and map it onto itself again. For 4, it would be instead 90 degree, a 90 degree turn, a 90 degree turn, a 90 degree turn, and another 90 degree turn. Each time would bring it onto itself. And 8, they would have to be 45 degree turns, would map them onto themselves. Well, what I'm going to do is take a few examples of this. What we want to do is pick a point, and I'm going to pick the point 3 comma 0, and I'm going to assume that that's like a ball that's tied to a string that's tied again to the origin. And what we want to do then is to rotate that through 45 degrees. If there were 8, I would have to be able to turn every 45 degrees and map the object onto itself. But since the length of that line is 3, it's going to still have to be 3 when I sweep through 45 degrees there. And since I'm at the point 2 comma 2, then the length of the line connecting the origin to the point 2 comma 2 would be square root of 8, which is not 3. So by turning 45 degrees, I don't map onto that point there, and so the answer 8 is going to be no good. Next, I want to look at whether or not there could be 4. If there were 4 motions, then it would have to mean that, again, this is a symmetric diagram here, every 90 degrees I would have to map the object back onto itself. But again, starting with a point at x is 3, y is 0, and that point is tied by a string to the origin, if I were to then sweep through 90 degrees, then I would end up that x is 0 and y is 3. Sweeping through 90 degrees, and again, since that point does not map onto the other point there, I don't need to worry about the rest of the diagram because it's not going to map onto itself at for 90 degree turns. So C is also out. For 2 turns, it would mean that I would have to be able to go 180 degrees and map onto itself. And so once again, I start with my point at x is 3, y is 0, and when I map that through 180 degrees, I now get the point negative 3 comma 0. And since that one works, I think again for 180 degrees it would be on a straight line, and I believe that you can see for each of the other points, mapping them through or along a straight line gives us a point that is also on the graph. And I'm not going to continue that, but you should be able to see that, that is the case, that it will continue to map onto itself. And if we were to do that again 360 degrees, obviously we'd be back to ourselves again. So there should be 2 answers, or 2 angles theta. One is 180 degrees or pi, and the other is 360 degrees or 2 pi, wherein the object will map back onto itself. So since there are 2 answers, there cannot be one, and the answer to this problem would be B.